Hello guys, welcome to another episode on data analysis series, and today we'll be looking at regression analysis. In our previous video we looked at correlation analysis, and we use this same data set for correlation analysis, and we are going to use it for regression analysis. Talking about regression analysis is a statistical tool that is used to predict or explain the relationship between a dependent variable and one or more independent variable. The dependent variable is also known as the outcome, while the independent variable is also known as a predictor. Here we will be looking at simple linear regression and multiple linear regression in SPSS. So at first we are going to check the relationship between the charges variable and the age variable. To do this, click on Analyze. From Analyze, scroll down to where we have regression and select linear. So our dependent variable here is the charges, while the independent variable is the age. So I'll select the charge variable and click on the arrow to move it to the dependent box. Then I'm going to select the age variable and click on the arrow to move it to the box. So from here we can click on statistic to check and ensure that the estimate and the model fit are marked. If they are fully checked, then you can go back and click on OK. So here is the output for the regression analysis we carried out. We have 4 tables here, but 2 tables are the most important table for your interpretation. That is the model summary and the ANOVA table. For the variable entered / removed table, it just shows the variable, and here is telling us that A is the dependent variable, which is charges, and B is the independent variable. In this case, our independent variable is age. So to the model. On the model we have the number of model, the R square, the adjusted R, and the adjusted R square, and the standard error of the estimate. Now the R is the correlation, is a Pearson correlation between the 2 variables. That R we are seeing here. And the Pearson correlation between these variables is 0.299, which shows a weak positive relationship. That is what it indicates. It indicates a weak positive relationship. And here we have our R square to be 0.89, and this 0.89 means that the age explains 8.9% of the varieties of the variability in the charges. The remaining 91.1% is due to other factors that are probably not included in this model. That is the interpretation for this particular R squared. And we have our R, the adjusted R squared to be the same. Then we have the standard error of the estimate. And this particular standard error of the estimate represents the average deviation of actual insurance charges from the predicted values. On the next we have the ANOVA table. For the ANOVA table as well, we have the model, we have the sum of square, we have the degree of freedom, then we have our mean square, the F, and the p-value, the significance. Now you can actually interpret this ANOVA table using 2 columns from here. That is the F column and the p-value column, which is the significant column. Remember, on the table here it shows us what our dependent and our independent variable means. Our dependent variable is the charges, our predictor, which is also constant, and is the independent variable, is the age. Now I can't interpret this for you with mouth, because we need to cross-check the value we have here with the F ratio tabulated value. That is using F ratio table, the F tabulated value using F ratio table. before we can make our decision. But we can actually interpret the p-value, which is the significance value, the significant level, using the value we have here, because this is a general statistical statement. If the p-value is less than or equal to 0.005, then it means that the relationship is statistically significant. But if the value you have for your p-value is greater than 0.005, then there is no statistical significance between that particular relationship. So in this case, since we have a value of less than 0.001, then we can say that there is a statistical significant relationship between the model. Or we can put it in this way, that the model is statistically significant, meaning that age has a real effect on charges. So that is just a brief summary, a brief interpretation for this output, and I have done justice by interpreting 3 of the table, whereas these 2 are the major one you need for interpretation. Next, let's get back to our data and also look at how to carry out a multiple linear regression. To carry out a multiple linear regression, all you need to do is click on Analyze, then go to Regression and select Linear. So in this case, we already have our charges there, so I can add other variable to the independent variable, like the BMI, and the number of students. Then I'll click on OK. So this, now we have, as you can see, since we are dealing with more, you see that there are changes in the value, but the table is still the same, but there are changes in the value. This one is from multiple linear regression, and there are changes in the value, and your interpretation is still the same. Like when we are having this one to be how is it called, the arrow here is for the multiple linear regression. We have the Pearson correlation to be 0.347, which shows a moderate positive correlation between the variables. And as you can see here, this one happened to explain 12%. So this is it. The table is the same. Know the first way we interpret the first one, then you can interpret this second one as well. So this is just where we stop in regression analysis for this particular phase 1 for Asan Tech Hope. So in our phase 2, we'll go deep into other regression analysis like logistic regression and all that. See you guys in the next episode.